All right, here's another standard sort of problem. We have an inclined plane, so 37-degree incline again. And I put a 3-pound weight on here and then attach that to a string which goes over a pulley, frictionless, weightless pulley. And attached to the other end is an unknown weight. The 3-pound weight is moving up the plane with constant velocity, which means that the weight is falling with constant velocity. And the coefficient of sliding friction, the coefficient of kinetic friction between the 3-pound weight and the incline is 0.1. Now I want to find out everything I don't know. And essentially everything I don't know are the normal and frictional forces on this guy, the tension in the string, and the unknown weight. Okay. So, choose a body. I'll choose the 3-pound object. Find all the forces on this object. Okay, well, there is its own weight, which is 3 newtons down. Actually, let me write that over here. There is a normal force, N, like this. There's a frictional force, F, like this. There is a tension in the string, T, like this. And that's everything. So now we want to say, okay, how shall we choose our coordinate system? And what I will do is choose a y-axis like this and choose an x-axis like this, where this is the positive y direction, this is the positive x direction. So, back here, and say now let's resolve all our forces. So if we resolve our forces, T, N, and F are already resolved in this coordinate system, as long as I'm careful with my signs, with my SIGNs, and the 2 components of the weight are like this. Okay, and this is 37 degrees here. And so this is, let's just say 3 sub x is equal to minus 3 times the sine of 37, which is minus 3 times 0.6, which is minus 1.8. 3 sub y is equal to 3. Okay, it's also negative, so I'll put that minus sign in. Minus 3 times the cosine of 37, which is minus 2.4. And therefore, we can proceed. Let's go here and say, okay, the sum of the forces in the x direction must be 0, and the sum of the forces in the y direction must be 0. I'm going to start with the y direction. because we have minus 2.4 plus n equals 0. And that tells us that n must be equal to 2.4 pounds. If we know what n is, now we know that the frictional force is mu sub k n. And so that's equal to 0.1 times 2.4, or 0.24 pounds. Now we can say the sum of the forces in the x direction is minus F, because F is pointing in the negative x direction, plus T, minus 3 sub x, which is minus 1.8. Okay. So that's equal to, that tells me that T is equal to 1.8. F is 0.24, so it's 2.04 pounds. Now that I know what T is, now I can, well, basically, what I have is I have the tension, and so finally I need to find the weight. In order to find the weight, I need to choose another body, and I will choose W. Okay, and W is the force down on this object, and the force up, of course, is T, but T we know, 2.04, and so the weight is 2.04 pounds, and we're now all done. Okay? All right. So I'll leave a little exercise for you. The little exercise is as follows. Take this and make the motion go in the opposite direction. Okay? That is to say, suppose that things are suppose that the motion now is down this way, so that the 3-pound object is sliding down the incline with constant speed, and this guy's going up with constant speed. How does that change things? Okay, what you will find is that the weight has to be different for it to go with constant speed this way and for it to go constant speed this way. And I will tell you what the answer is that you should come up with. You should come up with, in that situation, the weight is 1.56 pounds. Okay, so the new weight should be 1.56 instead of 2.04. Okay? All right, that's it for this example.